Architecture DCISIONS. Splitting your monolith won't fix a slow team. It just spreads the same problems across a network. Splitting your monolith into microservices won't fix a slow team. It just spreads the same problems across a network. The trap: most teams don't choose microservices. They inherit the decision from a blog post. Most teams don't choose microservices for a real reason. They inherit the decision from a conference talk or a blog post. Bad REASONS2 split. None of these are engineering reasons. Netflix does it is not a reason to split your system. Neither is wanting to try new tech or thinking it feels more modern. Netflix does it, wanting to try new tech, feels more modern. The real question isn't microservices versus monolith. It's where you draw the boundary. The real question isn't microservices versus monolith. It's where you draw the boundary between parts of your system. Cost 1. A function call is free. A network call never is. A function call is free. A network call never is. In a monolith, your checkout code calls your payment code in the same process, a few nanoseconds, and it can't fail on its own. Split it into a separate service, and that same call crosses a network. It needs a DNS lookup to find the address, a TCP handshake to open the connection, and TLS encryption to secure it. Then your data gets serialized, turned into bytes to send, and back into an object on the other end. And now, the call itself can time out or fail halfway. What you now own. Every remote call adds new failure modes. Every remote call adds latency, the chance of partial failure, and the cost of turning objects into bytes and back. Object, 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 object. You didn't remove complexity by splitting the service out. You moved it into new code, timeouts that give up after a set time, retries that try again with a growing delay between attempts, and a circuit breaker that stops calling a failing service completely for a while, so it can recover. Cost 2. One database transaction became two systems that can disagree. One database transaction just became two systems that can disagree with each other. In a monolith, saving the order and charging the card happen in one database transaction. Both succeed or both roll back. Split them into two services and you lose that guarantee. The order saves. The charge succeeds on the payment side, but the network drops before payment can confirm it back to the order service. Now you have a paid order that thinks it failed. You get some of that consistency back, but you pay for it in code. A saga breaks one transaction into a chain of steps that can each be undone if something later fails. An idempotency key makes it safe to repeat the same request without causing harm twice. And eventual consistency means users might see slightly out-of-date data for a moment before everything catches up. Cost 3. You used to deploy one thing, now you deploy a fleet. You used to deploy one thing, now you deploy a fleet. One code change used to mean one deploy. Now it means versioning every service so they stay compatible, coordinating who deploys before whom, tracing one request as it crosses 10 service boundaries, and running far more infrastructure just to keep it all visible. 3 real costs: network calls, distributed transactions, deploy complexity. None of this is free. Network calls, distributed transactions, and deploy complexity. None of this is free. So why split AT all? Because 2 real benefits are worth paying for, sometimes. Because 2 real benefits are worth paying for sometimes. Benefit 1. Scale only the part that's hot. In a monolith, one busy feature forces you to scale the entire app. Split it out and you scale only the part under load. A real example: checkout gets 10 requests a second. Image processing gets 10,000. Checkout gets 10 requests a second. Image processing gets 10,000. Scaling them together wastes money. Benefit 2. Ship without waiting on another team. In a monolith, every team shares one deploy. One broken test blocks everyone. Split by team ownership, and each team ships on its own schedule. The catch: that benefit only shows up if you split by team, not by code. That autonomy benefit only shows up if you split along team boundaries, not just along lines in the code. The failure mode: split the code without splitting the teams, and you get the worst of both worlds. Split the code without splitting the teams, and you get the worst of both worlds. This failure mode has a name. This failure mode is called the distributed monolith. You've split the code into 10 services, but they're still owned by one team, still tested together, still deployed together, and still changed together. You paid every network cost we just covered, and you got none of the team autonomy benefit. This is what happens when you split by code, not by team. How to spot it? One symptom gives it away. If one small change means opening 5 repos and coordinating 5 deploys, you're not running microservices, you're running a distributed monolith. The framework: forget the religion. Use one practical test. Forget the religion. Use one practical test instead. Here's the one test that matters more than any diagram. Before you split a service out, ask this: can the team that owns it ship a change without touching another team's code and without waiting on another team's deploy? If the answer is yes, splitting is probably worth the network cost. If the answer is no, if shipping still means coordinating across teams, splitting won't fix that. You'll just be coordinating across a network instead of across a code base. Apply the test. Same test, 2 different answers. If teams still have to coordinate to ship, splitting won't fix that. Fix the coupling first. If the team can already ship alone, split along that boundary. The practical path: most systems should start monolithic. Most systems should start as one deployable monolith. Extract a service only when a real team boundary appears and the lever test passes. The rule: split for team autonomy you actually have. Never split for hype. Split for team autonomy you actually have. Never split because it's trendy. Before you split anything, ask these 3 questions. Before you split anything, ask if a real team boundary exists, if that team can already ship alone, and if the network cost is worth it. Real team boundary: can ship alone today. Worth the network cost. The takeaway: microservices aren't better. They're a trade. Network cost for team autonomy. Microservices aren't better than a monolith. They're a trade. Network cost for team autonomy. Make sure you're actually buying the autonomy. Keep LEVELING up. Every architecture decision is a trade. Now you know which one you're making. Every architecture decision is a trade. Now you know exactly which one you're making. If this helped, subscribe. New deep dives on Dev Level 13 every week.